Alright, let's consider the following problem. Consider a circuit with an ideal 60 Hz generator with a peak voltage of 120 volts connected to a 2 Henry inductor and a 2 ohm resistor connected in series. Find the expression for the current as a function of time. So it's important to basically start out by drawing a picture of this. So let's draw a picture. So let's have this is our generator. It's 120 volts at 60 Hz. And we're going to connect it in series to first a 2 Henry inductor. So let's put that inductor there and there. And a resistor. Let's draw it out this way. There's my resistor. And connect it back. And this is a 2 ohm resistor, a 2 Henry inductor. Alright, so first we're going to use Kirchhoff's law. Start at this point here, go across this thing. So this will just give me basically V 0 cosine omega t. Well, let's make the I move in this direction. Alright, then across the inductor, that's basically minus L di dt. And then across the resistor, minus R times I. And then basically back to the same point, everything is 0 now. Alright, okay, so once I have this set up, I can go ahead and try to basically solve for it. In order to do this, let's go ahead and think about, right, okay. So in order to solve this particular problem, we will first complexify it. Okay, and so what that means is cosine omega t goes to e exponent to I omega t, right? Okay. In this case, this omega here is 2 pi times the frequency, and the frequency is 60 Hertz. All right. Okay, so I'm going to complexify like this first. So let's basically write this thing down then. This is going to be V0 exponent I omega t minus L di dt minus R times I. I'm going to divide by L, 0, all right? So that goes to 1, all right? Okay, so let's write down my final equation, which will be simpler. Let's see, I will write it like this, di dt plus R over L times I. So I'll move this over to, I'll make these all positive, move it over the side, and I'll flip the sign. That's going to be equal to V0 over L exponent I omega t. All right, so now I have to put the appropriate guess in. Now this is what's called inhomogeneous equation. And so as a result, the guess has to be the following. So the guess is I is equal to some amplitude exponent I omega t. All right, so I'm going to plug that in. Okay, so I'll plug in. And then what I have is d by dt a exponent I omega t plus R over I times a exponent I omega t is equal to V0 over L exponent I omega t. All right. Okay. So we're going to go ahead and solve this equation here. So that's basically this thing accident. This pulls on I omega here. So it's going to be I omega A exponent I omega t plus R over I A exponent I omega t is equal to V0 over L exponent I omega t, right? So miracles and miracles happen. The exponentials all cancel each other out. And now we can solve for basically A, right? So A is going to be equal to, if we do this correctly, it's going to be equal to V0 over L divided by, let's get this right now, this is going to be R over L plus I omega, right? Okay, so that's our answer there. Now we have to basically convert this to something that looks a little better. So I'm going to basically multiply by a special form of 1, r over L minus I omega, r over L minus I omega. Okay, so this thing down here will give me something that looks like r over L squared plus omega squared. And this thing will just give me whatever that's going to give me. So let's write this thing down. This is going to be V0 over L divided by R over L squared plus omega squared. And then this multiply times R over L minus I omega. Right? All right. And so this is A, and this is a complex number. And so you could rewrite this as basically sum A exponent I delta, right? Which you can think of as basically A cosine of delta plus A IA sine of delta, all right? And so that means that you divide the imaginary part by the real part, you get a tangent. So that basically implies that tangent delta is equal to the imaginary part of A divided by the real part of A. Okay? All right. So I'm going to copy this to the other side, and then we're going to keep pushing this forward. I'll just copy on this. Just copy it on lacking paper. Oh, here we go. I'll just copy it to this side now first. Okay. So I'm going to write down what A was again. So A was equal to V over L divided by R over L squared plus omega squared. And then this is going to be R over L minus I omega. And what we've basically determined last time from previous is the tangent of delta is equal to the imaginary part of A over the real part of A. Okay, so let's go ahead and use this form here. So if you divide the imaginary part here, divide by the real part, there's a common factor that will cancel out. So it's just going to be tangent delta is just going to be omega minus omega divided by R over L. Okay, so that's the first thing, right? Now the second part of it is that we have to figure out what this capital A is. This is going to be, these things are real, right? So let's determine what A is. So A, right? You can just go ahead and just do this actually if you wanted to, but basically you're computing this thing out, okay? And if you do that correctly, you're gonna get something that looks like this: V0 over L divided by the square root of R over L squared plus omega squared, right? Okay, so now we are done, okay? Let's go ahead and plug in a few numbers if we want to get this right. So first of all, this is minus omega, right? So minus omega is minus 2 pi f, where that is 60 hertz. And then divided by r over L. Well, this was, the r was 2 divided by the inductance of the inductor, which was basically 2 henries, right? So this is going to be basically minus 2 pi times 60, right? Okay, tangent delta. Okay, I'll let you go figure out what that needs to look like. Maybe I'll do that by hand here. Okay, I'm going to compute this thing out. And go ahead and compute this thing out. So I'm going to compute out minus 120 times 3.341. All right, and then I convert that to degrees. so this is, roughly speaking, this is about minus 89 degrees, actually. Very close to 90 degrees. Okay, which, yeah, this is a very big number. So, okay. And now the second part of it, what? Okay, delta, right? Now the second part of it is that to compute what A looks like. So A, that's going to be equal to, let's see, so the voltage was 120 divided by number of henries is 2 divided by square root of basically 2 over 2 square, right? 2 ohms divided by 2 henries squared, plus now again a fairly large number, so that's just going to be 2 pi times 60 hertz again, right? Squared, right? So let's go ahead and do that. I'm going to just compute that out. So this is going to be 1 plus okay, so right, so that's 377, so that's 60 over 377. That's right, okay. And now right, so that's roughly about 0.16. Okay, so now we can come up with the final thing. Okay, I was this, all right, which is actually equal to A exponent I delta exponent I omega t, right? So I'll write that down. I is equal to A exponent I omega t, which is A exponent I delta exponent I omega t, right? And this is going to be equal to A exponent I omega t plus I delta, all right? Okay, so let's plug everything in. So this is going to be equal to, so A was 0.16 exponent, right, I omega t plus I delta, which is basically I minus something roughly pi over 2. Okay, it's technically not, it's actually 89 degrees, so I'll put that as 89 degrees, put that in quotes so I don't mess up later. All right, and so what you end up getting is something pretty simple now. So this is going to be, all right, so this is going to be 0.6 exponent, well, let's get the right part right. So now this is I. Now this is complexify I, so I need to take the real part of this thing. Okay? And the real part of the thing just brings out cosine out of this thing. So it's going to be equal to 0.16, right? Times the cosine of 2 pi f t, f is going to be 6 degrees, minus 90. So roughly speaking, this is going to be equal to, let's see, it's a minus 90. So this is going to be equal to roughly something like 0.16 sine of 2 pi ft. It's not quite sine, all right, because it's not quite 90. It's actually 89 degrees, all right? So if we actually really want to do it correctly, it's going to look something like this: 0.16 cosine 2 pi f times t. And if you want to do it right, you have to convert the 89 degrees to something that is in radians. So this is actually be basically minus, I have this as 1.57, right? It's close to that. All right. And so basically that is the answer. And of course you want to do it right. This is in amps. All right. That's it.